The Widefoot Enterprise Emulation environment is a risk-free environment that allows interested parties to explore alternative enterprise-level configurations on direct and supported investment decisions. Widefoot is part of PNNL's Center for High-Fidelity Science in Operational and Information Technology, commonly known as HiFiSci. HiFiSci is comprised of several components. The Cyber Physical Research Lab, or CPRL, provides lab space and equipment for simulating and emulating operational technology environments. PowerNet provides capabilities for building hands-on environments in which users set up and conduct operational technology experiments. And CyberNet is similar to PowerNet in that it gives users hands-on testing capabilities, but it is focused on IT experimentation. Widefoot makes use of CPRL, CyberNet, and PowerNet capabilities to design, build, and execute IT or OT experiments on behalf of stakeholders who don't have hands-on skills or needs. Widefoot and the entire HiFiSci effort has a mission to strengthen the state of U.S. IT and OT cybersecurity through the advancement of the science of cybersecurity. Widefoot is proud to present PAM, a short video demonstrating that thoughtful integration of commonly used cybersecurity tools can greatly improve situational awareness for any cyber defense team. Funded by the Department of Homeland Security, this video demonstration of PAM, short for Patch Management, portrays real IT enterprise behavior played out in Widefoot's enterprise emulation environment. In this video, two alternatives of a fictitious enterprise are instantiated. One instance, an as-is or right-now enterprise called DARN, for department or agency as they are right now, uses tools in a stovepipe fashion, while the other instance, a next-generation solution, DANG, for department or agency next generation, integrates the same tools into comprehensive views on the enterprise. In this video, the same scenario is played out on both DARN and DANG, clearly showing that situational awareness can be greatly improved without additional investments in tools or training. The Widefoot provides this capability through virtualization, automation, and orchestration. Using the analogy of traditional building construction, Widefoot uses blueprints and construction phases to build, provision, and instantiate virtual enterprises on which users can conduct experiments, test drive tools, and demonstrate capability. PAM is one example of a demonstration, so sit back, relax, and enjoy the PAM video demonstration. For demonstration purposes, our enterprise is the Flagpole Installation Commission, a fictitious commission with real-world government agency mission and purpose. FIC was derived from a cross-section of department and agencies that we interviewed for the DHS work. We will be demonstrating patch management using two scenarios, each played out in the DARN right now and DANG next generation instances. In both environments, we have logs from the same sources: WSUS, system events, Active Directory, and an email server. In our first scenario, somebody has been gone for an extended period of time and their system has been turned off. That person is now returned and the system is back online but missing patches. How do we notify users that their system is vulnerable, and what actions can be taken if those users ignore the notifications? In the DARN environment, a system administrator has access to WSUS to see the status of computers in the enterprise. If they find a system that is unpatched or failing to install patches, they can try investigating the event logs on that system to find the root cause, but that may not tell the whole story. If the unpatched system does not report to the WSUS server, the system administrator is blind to the vulnerable computer. In the DANG environment, we have provided dashboards for various roles that pull together all of the different sources of data into comprehensive views. A system administrator can still view the status reported by WSUS, but using the patch management dashboard, they can see the status of all systems in the environment, regardless of whether or not they're reporting to the WSUS server. Now we can see that we have a few systems that are not communicating with the WSUS server and remain unpatched. Using the system status dashboard, we can see which systems are offline or have recently been offline for a period of time. The cybersecurity team also has a view for these data sources. The system administrator or cybersecurity analyst can drill down further into the details of a particular system to get the operating system, when it was last rebooted, patches that have been installed, and contact information for the user and the user's manager. The same data that builds these views can also be used to create alerts. For example, you could automate sending emails to owners of unpatched systems, generate alerts for systems that have been offline for an extended period of time, or notify the help desk that a system needs to be worked on. With the dashboards provided to the help desk, they can see all of the computers a customer has used and view the details for those systems, including BIOS information, Metrics like CPU, memory, hard drive space, how long it has been online, user logins, media connected, executables run, and even registry changes. These comprehensive views provide a much more complete picture of the entire environment. In our next scenario, the cybersecurity team has been made aware of phishing attempts via cybersecurity communication channels, and they need to act quickly to investigate if their network has seen any activity. In the DARN environment, the cyber analyst investigation is slowed because they either have to rely on the email administrators to search the logs for them, or they can search the logs themselves if they have been provided access. If they find systems involved, they will need to search the event logs for each system to look for actual occurrences of compromise. In the DANG environment, the cyber analyst is able to quickly search for emails with matching indicators. They can quickly determine that someone has received the email and forwarded it on to someone else. The dashboard associates the emails with the host that sent them, and the cyber analyst can drill down to each host and see privilege escalations that occurred. The PAM video shows that using a side-by-side comparison of two fictitious enterprises is an excellent way to demonstrate the use of an enterprise emulation environment to prove out new cybersecurity solutions. Widefoot can be used to emulate realistic enterprises for many purposes, including demonstrations such as PAM, test drives of cybersecurity components, and science-based cybersecurity experiments. It can also be customized for different emulations. The Widefoot team continues to develop scenarios, tools, and network configurations, as well as a metrics framework for scientific experimentation. Widefoot would like to thank the Department of Homeland Security Science and Technology Directorate and the staff of the Center for High Fidelity Science and Operational and Information Technology for supporting the Widefoot effort.